In this video, I will go over the Unit 4 review questions. It's important that you have tried these problems on your own before you have watched my explanation. Only watch these problems if you have attempted these on your own and still need help with certain problems. There are going to be 20 questions on your quiz for Unit 4 that are very similar to these 20 questions on the review. Let's look at question number 1. Consider the function g of x equals negative x squared in relation to the parent function f of x equals x squared. So that's the parent function of a quadratic. Sarah claims that the function is a reflection over the x-axis, and Michael claims that the function is a reflection over the y-axis. So you can draw yourself a picture or even use the graphing calculator. So our picture here, the basic parent function f of x equals x squared, that would be a parabola opening up. The function g of x would make that open down, because our a right there is negative, it opens down when that a value is negative. You could also go to the graphing calculator, hit that y equals button, of course have it turned on, y equals button, and type in each of the functions. So x squared is the parent function, and negative x squared, and hit that graph button, and it shows you the same picture. The first one is the first function, the second one is the next function. And so we can easily see that that's going to cause a reflection over the x-axis. This is the x-axis. That negative a value makes it open down and reflect over the x-axis. So who is correct? Sarah is, because it does reflect over the x-axis. Let's look at question number 2. It says the function is shown on the graph. Which statement is true? So we see a quadratic that is graphed. Let's look at our choices here. Well, domain is always going to be all real numbers for a quadratic. We have this quadratic that opens in both directions here. It's opening down, but it's going to touch every x value. So we will not pick A or B, because the domain would not be less than or greater than a particular number. It's going to always be all real numbers for a quadratic. That's always true. So now we've got to talk about our range. So look at your y values. The highest y value that our graph reaches is that vertex. So that points at 1, 3. The highest that graph reaches, so let's just highlight it if we need. Here's our y values. It actually stops there at 3. It does not go beyond that y value of a 3. So we are going to say that y is going to be less than or equal to 3. We would not say greater than or equal to 1, because here is where our graph stops, is at 3. 1, it went beyond that, and yes, it did go beyond greater, but it's also touching all these less than that 3. So answer choice C would be the one to pick. Let's look at question number 3. We're going to find the axis of symmetry and vertex of this equation. Because this is in standard form, we'll need the axis of symmetry formula, negative b over 2a. So in order to do that, we need to start with our a, b, and c values. So a is 3, b is negative 18, and c is 7. We don't really need the c, but it's good to go ahead and list it. So our axis of symmetry formula, negative b, make sure you use that 1, over 2a of negative b over 2a. So if you need to write out that formula, that's what we're using, negative b over 2a. And then we work it out. Negative times negative is a positive. 2 times 3 is 6. And we can divide to give us a 3. So that gives us our axis of symmetry number. Our vertex is going to be 3 comma something. So we've got to find that other value. Well, if we know 3 is our x value, plug it in. So y equals 3 times 3 squared minus 18 times 3 plus 7. And you could use order of operations to be quite honest with you, you may make mistakes when doing order of operations, so it may be best for you to type it in the calculator. So type in exactly how you have it written, 3 parentheses, and we're going to square it. Now if you had a negative, you have to use parentheses, so be careful with that. Minus 18, and do our parentheses for our 3, and then plus 7. So I always recommend when plugging in a number that you have used those parentheses. It gives us a value of negative 20. So that is our vertex 3, negative 20. Again, you could use the graphing calculator to actually see this in the table. If you hit that y equals button, let's clear out our previous equations and type in 3x squared minus 18x plus 7. We did our axis of symmetry work, so if we go second table and scroll to where we had, oh, wrong direction, scroll to where we had the 3 as our axis of symmetry, we can check our work and see that negative 20 does give us our y value. And hopefully you can make sense of the table also, because quadratics are symmetric. Here, that vertex in the middle, notice the pattern on either side. So that is another good way to check that you're doing this correctly. Once you find your axis symmetry and vertex, look in the table and see, do you see that symmetry on either side of that, to know that that's really truly the vertex. Let's look at question number 4 now. It says the formula for throwing a baseball in the air is represented by, and gave you this function, where h of x is the height of the ball and t is the time in seconds. What is the maximum height that the baseball will reach? So if you imagine throwing a baseball, because our a is negative, we know that this is going to open down. So if you've thrown a baseball, it's going to fly up into the air, and then gravity's going to help pull it back down. So we need to find the maximum height. So pretty much we're just finding the vertex. So let's do that work again. A equals negative 16, B is going to be 12, and C is 40. Plug it into your axis of symmetry formula so you can find the x value. So negative b over 2a. So plug in your b, plug in your a, being very careful that your b is in the top and the a is in the bottom. Don't flip-flop those. I see that often with students' work. So negative b over 2a. Make sure you put them in the correct spots. So we get negative 12 over negative 32. And your calculator will do all of that for you. So if you have to, go alpha y equals and type it all in. So negative 1 times 12, and then 2 times negative 16. So it will calculate all that for you. I've multiplied and then I'll divide by myself. So negative 12 divided by negative 32 gives us a decimal 0.375. Or if you've typed it all in the calculator, it gave you 3/8, which is the same. So if you go math decimal, it will change it to the decimal if that's what you prefer to work with. So I have that x value. I'm going to plug it back in so I can find our height. And I guess technically for this equation, it's going to be our t value since it's talking about time instead of x. All right. So we want to find h of 0.375. So we're going to plug in negative 16 times our 0.375. We're going to square it. We're going to do 12 times the 0.375. And this may have been the time we should have just done the fraction because it's getting pretty lengthy to write it out. Whatever works best for you, decimal or fraction there. So let's work it out on our calculator. So negative 16, we're going to type in our decimal 0.375 and square it. Add 12 and multiply that with 0.375, not squared there, and then add 40. So of course make sure you've typed it in carefully. So if that means retyping it once again, or like we've learned, go to y equals, type in that function that you were given, and go to second table and you compare your answers there as well. problem is with this one, with the decimal, you'd have to kind of adjust your table settings so that you could see that value. So we have 42.25 as our maximum height, and that is in, it does not say, does it? So it's just 42.25. We don't know if it's feet, inches, yards, whatever the units are going to be here. The answer key says meters, but that does not ever say, it just says the height of the ball. So whatever units are given, probably should have said in the problem meters. So question number 5. Select the graph of the function. Now when we talked about factored form, we could find our our x-intercepts by setting our factors equal to 0. So x minus 4 equals 0, x plus 2 equals 0, and we can match our x-intercepts. Let me write that down since I keep saying the wrong thing. We can find our x-intercepts by setting our factors equal to 0. So when we add 4, we get an x equals a 4, so that would be at the point 40. We subtract 2, so x equals -2, that would be at the point 20, taking that x, and then our y value would be 0. So match it with your graph. Where do you see a +4 and a -2 as the y-intercept? So that is answer choice A. Notice answer choice B, the opposite is occurring. We have a -4 and a +2, which I commonly see students picking that because they see that as the factors. The factors are -4 and +2, but the x-intercepts are going to be opposite. So +4 and -2. Number 5, we're going to choose answer choice A there. Let's take a look now at number 6. We're going to find the x-intercepts of the function. So we just practiced this with a graph. Now just to name the x-intercepts. X plus 7 equals 0. X minus 5 equals 0. We can set each of those equal to 0 and solve by subtracting 7 and adding 5. So for the first one, we get an x-intercept at -7, 0, and then the next one we get an x-intercept at 5, 0. So to find those x-intercepts, you set each factor equal to 0 and solve those equations. Question number 7. Now for vertex form, we're going to find the vertex and determine if it is a maximum or minimum. So first of all, for our vertex, it's going to be the HK value. So for H, we write down the opposite of what we see. We see a negative, so I'm writing down a positive, so the opposite of what I see. For the K value, we write down exactly what we see, the exact value. So that is our vertex. In order to determine if it's a maximum or minimum, look at your A value. So here A equals a +1. Right there, it's a +1 at the very beginning. That's where we're looking at. So because A is positive, this graph is going to open up. When A is positive, our graphs will open up, and then just picture, where's your vertex at? There's that vertex we just found, 7, 9. Is it the highest point or the lowest point? It is the lowest point, so it's going to be a minimum. So when we find our vertex, we name our HK, and then to know if it's a max or min, just look back at your A value. It tells you if it opens up or down, so that you'll have that highest or lowest point. Question number 8. We're going to determine the range of the function. So in order to know the range of the function, it does help to know your vertex. So again, opposite and exact. So we're going to write down a -6 and an 8. Opposite of this one, exact of that one for your H and your K. It also will help to know, does this graph open up or down? So our A value is a -1. Right, here's where we're finding that. Because A is -1, it's going to open down. This will help me know which way our range values are facing. Range stands for y's. So for our range, we're going to be considering what y values is our graph going to reach. Well, if we know here at our vertex, 8 is the highest point it's going to reach, because that's the y value of our vertex, then our range is going to be all the y's such that y is going to be less than, because that vertex is the highest point, so our y's are going to be less than that 8. And it can be equal to, because again, there's a point right there at that vertex. So our range values are going to be less than or equal to 8. Start by finding your vertex. Ask yourself, does the graph open up or down? That will tell you to know to say less than or greater than, and then use the y value of your vertex. Question number 9. The function f of x equals x squared is translated 4 units left and 6 units down. We're going to write a function g of x in vertex form. So first let's talk about 4 units to the left. If we had a left and right movement, that was an h value. So 4 units to the left, left would be a -4. And 6 units down, so that's our k value when we want to go 6 units either up or down. When we're going 6 units down, that's going to be negative. So the h comes from that it's 4 units left, that's your left or right movement. Your k value will be moving up or down, and so we went 6 units down, so that's why it is negative. So we want to find a function g of x in vertex form. Well, vertex form, we put our a value first, which we don't have an a value, it's just a plain old function here as far as opening up or down. We do x minus our h. Well, h is -4, so minus a negative and square that. And then your k value, so plus k at the end. So vertex form, we'll write it over here to the side, is a times x minus h squared plus k. So we said our a, we don't have it changing, opening up or down. Our h is what moves it left or right. Our k is what moves it up and down. So once you plug in those numbers, we really could kind of clean this up. Minus a negative is the same as adding a positive. So you just say plus 4. Don't forget your squared. And plus a negative is really the same as just minus. So when we want to go left 4, we should see a plus 4 in our function. And when we want to go 6 units down, we should see a minus 6. Let's look now at question number 10. We're going to write a function in vertex form for the graph. So here we see this graph. Let's first find our vertex since we're writing it in vertex form. So 3, 6. Again, to remember vertex form, we just wrote it on the previous question, so let's write it again here. We have our a times x minus h squared plus k. So that is vertex form. So we're going to plug in our numbers based on what we have. So f of x equals, well, first of all, our graph is opening down, so our a value needs to be negative. So a equals a negative because it opens down. So we're going to start with that negative out front. Then we do x minus our h value, tells us how many places to the left or right it has moved. So it's moved to the right 3. That means our h is 3. So we'll plug in a 3. But again, remember, we're going to see a minus 3 because we'll see the opposite of what our x value actually is. So if our h is 3, we see a negative 3 in our function. Then we're going to square it and then use our k value. Our k value tells us how many it has moved up or down, and we already found that it's up 6, so plus 6. You could always check this in the graphing calculator. We haven't done that in a while, but always remember the graphing calculator can help you. So if you have a picture of a function and you're writing a function, go to y equals, type in negative parentheses x minus 3 and square it, add that 6 at the end. So type in what you think the function is going to be and hit that graph button. Look and see, does it look like the picture that you're trying to match it? Now it is a little, different, so you'll have to count just to make sure, or you could always go to the second table and find that vertex at 3, 6, if that helps you match it up better. But if you look like it's close to what your picture is on the question, then you can feel more confident that you've written the correct function there for the vertex form. Let's look now at question number 11. We're going to use the graph below to identify the following things. So there's several things we've talked about with quadratics, and we're going to use this graph to name each part of those. So first, the axis of symmetry. That is that line that cuts it symmetrically down the center. So that axis of symmetry line, ours is at 1, 2, negative 2. So it's x equals negative 2 for our axis of symmetry line. Now we want to know, is our vertex a maximum or minimum? So looking back at your graph, that is where the vertex is at, where it changes that curve from increasing to decreasing or decreasing to increasing depending on your graph. So in this case, it's changing from increasing to decreasing. That's that vertex point. Well, that's the highest point, so here it's a maximum. Let's name that point, the ordered pair. So negative 2, comma 9, negative 2, comma 9, and notice the x value of your axis of symmetry should match the x value of your vertex. Let's name the x-intercepts. We do have 2 here. There's one at negative 5 and one at positive 1. So we'll write those as our ordered pair. Negative 5, comma 0 and 1, comma 0. Remember, if they're x-intercepts, you should have a number in the x-axis or x position. The y value should be 0. You're not moving up or down on the y-axis. It's just left or right on the x-axis. So our x-intercepts, negative 5 and positive 1. The y-intercept, where does it cross the y-axis? Right there. So it's at 5. So this time we're going to put 0, comma 5. Because again, we want a number in the y spot of our point if it's a y-intercept. The domain of a quadratic is always going to be all real numbers. And our range, it depends on if the graph is opening up or down. So this one is opening down. So that means our range is going to be less than where that vertex was. That's the highest number it reaches, so 9. So our range is going to be y is less than or equal to, because there's a point there at the vertex, that 9 value. So a couple things to pay attention to. Our axis of symmetry is going to be the same as our x value of our vertex. Our range is going to be the same value of the y value of our vertex. Of course, the x-intercept and y-intercept are just points that are on the graph at those places, x or y-intercept. And the domain, always going to be all real numbers for quadratics. Watch the next video to finish up the rest of the review.